Welcome to our deep dive into the world of time travel.
Ooh, time travel.
It looks like you've gathered some fascinating sources.
Oh yeah, some really interesting stuff.
And you're ready to unpack one of humanity's oldest fascinations.
Yeah, one of the biggest ones for sure.
From ancient myths to modern sci-fi, the idea of bending time has always captured our imaginations.
Absolutely. It's been a constant throughout history, hasn't it?
But today, we're going beyond the fiction
Okay,
and exploring the actual science of time travel using your sources as our guide.
sounds good.
So,
Yeah.
where do we even begin with something as complex as time travel?
Well, maybe we should start with how our understanding of time has evolved.
Okay.
We used to think of time as this like unwavering, constant backdrop.
Right, like an arrow moving in one direction.
Exactly. But your sources point to a much more dynamic reality.
Okay, so something more complex than just that arrow.
Much more.
So what are we talking about here?
Or we're talking about Einstein's theory of relativity.
Okay, so relativity, that's a big one.
It's a game changer.
Can we break that down a little bit?
Of course.
Yeah.
Yeah, the key takeaway is that Einstein basically shattered this idea of time as absolute.
So time isn't this fixed thing that's the same for everyone everywhere.
Right, it's not this universal clock ticking at the same rate for everyone.
Okay, so then what is it?
He showed us that time is actually woven together with space.
Time and space woven together, what does that even mean?
It forms this fabric we call space-time.
Space-time. Okay, I've heard that term before.
Yeah, and this fabric can be warped and stretched by gravity and speed.
Hold on. Warped and stretched. How does that work?
Think of it this way. One of your sources talks about space-time like a trampoline.
Oh, yeah, I remember that analogy.
If you place a bowling ball in the middle,
Okay.
it creates a dip, right?
Yeah, like a dent in the trampoline.
Exactly. That's like a massive object, like a planet or a star warping space-time.
Okay, so the bowling ball is like a star.
Right, and the closer you get to that bowling ball, the steeper the curve and the slower time moves for you.
Wait, so time moves slower near massive objects.
Relative to someone standing further away, yes.
So it's not that time itself is changing, it's our experience of time that changes.
That's a great way to put it. It's all relative.
I'm starting to see why they call it the theory of relativity.
Exactly, and it's not just a theory.
So there's actual evidence for this.
Yeah, you pointed out how GPS satellites actually experience this phenomena.
Oh, right, because they're farther from Earth's gravity, their clocks run a tiny bit faster.
Precisely. And they have to be constantly adjusted to account for this time difference.
Wow, so that's proof that time is relative, not absolute.
It really highlights how time travel to the future is, in a very subtle way, already happening.
Wait, are you saying we're all time travelers?
In a sense, yes, we're all moving through time at slightly different rates.
Huh, okay. I'm trying to wrap my head around that.
Now imagine scaling that up, traveling at a significant fraction of the speed of light.
Okay, so like approaching the speed of light?
You could theoretically catapult yourself years, decades, even centuries into the future.
That's incredible.
Relative to Earth time, of course.
But what about traveling to the past?
Now that's where things get really tricky.
Your sources really delve into the complexities of that.
Yeah, because going back in time raises a whole host of paradoxes and challenges.
Like what kind of paradoxes?
We take the classic grandfather paradox, for example.
I think I've heard of that one.
It's the one where if you could go back and prevent your grandparents from meeting, would you cease to exist?
That's a tough one.
Right. And if you never existed, how could you have gone back in time in the first place?
It's a real brain twister.
It creates a logical loop that's incredibly difficult to unravel.
Yeah, trying to figure that one out could give you a headache.
And then there's the bootstrap paradox.
Oh, I remember reading about that one too.
It's the one where you travel back in time and give someone the plans for an invention that they later become famous for.
Like they get the credit for something that you actually brought back from the future.
Exactly. It becomes this closed loop where the origin of the invention is impossible to trace.
So like who really created it?
Right. It's a real head scratcher.
It seems like messing with the past could really mess things up.
Both of these paradoxes point to the potential violation of causality.
Causality, what's that?
It's the principle that cause always precedes effect, like a domino effect.
Oh, I see. So changing the past could disrupt the order of events.
It could unravel the very fabric of how events unfold in time.
And create contradictions we can't even comprehend.
Exactly. Our minds struggle to grasp those kinds of scenarios.
So how do physicists even approach these mind-boggling possibilities?
Well, your sources discuss some incredibly intriguing ideas.
Like what?
Like wormholes, for instance.
Wormholes. Those are like theoretical shortcuts through space-time, right?
Exactly. Think of it like folding a piece of paper and punching a hole through it.
To connect two distant points.
Precisely. A wormhole could theoretically connect Not only different points in space, but also different points in time.
Okay, but how realistic is that?
Well, as your sources point out, wormholes are incredibly theoretical and likely very unstable.
So not something we could just hop into and travel through time.
Not quite. One of the biggest hurdles is that they would require something called exotic matter to stay open.
Exotic matter. I remember you highlighted an article about that.
Yeah, it's fascinating stuff.
What's so special about exotic matter?
Well, it supposedly has negative energy density.
Negative energy density. What does that even mean?
Imagine energy like a battery. A regular battery has positive energy,
Okay.
but this exotic battery would have less than zero energy.
Less than zero. That's hard to imagine.
It's a mind-bending concept, and we've never actually observed anything like it.
So it's this hypothetical stuff with properties we barely understand.
That's one way to put it.
And it might be the key to stabilizing these theoretical tunnels through space-time.
It's a big if.
A really big if.
The challenges of creating and stabilizing wormholes are immense.
And the existence of exotic matter is still very much up in the air.
Very much so.
Yeah.
It's all still in the realm of speculation.
So if wormholes are such a long shot, are there any other potential avenues for time travel?
Well, your sources delve into a particularly mind-boggling idea, the multiverse.
Oh yeah, the multiverse, I've heard of that, but it always seemed like pure science fiction.
It is a mind-blowing concept.
Can you explain it in simple terms?
It proposes that every decision, every quantum event, could spawn a new branch of reality.
So like every time we make a choice, a new universe is created.
It's a bit more complex than that, but that's the basic idea.
So instead of traveling through time within our own universe, we could be hopping between different universes.
That's one interpretation of the multiverse.
So if you went back in time and changed something, you wouldn't be changing your own timeline.
You'd be creating a new branch of the multiverse.
A separate reality with its own unique history.
Exactly. It's a way to sidestep those pesky paradoxes we talked about.
Like the grandfather paradox and the bootstrap paradox.
Precisely.
It's a neat way to think about it, and it's a concept that's become popular in movies and TV shows.
Oh, absolutely. You mentioned how movies like Avengers, Endgame, and shows like Loki use this concept.
It allows for some pretty wild time travel stories.
Yeah, and it avoids getting bogged down in the logical knots of altering a single fixed timeline.
So we've covered the theoretical possibilities of time travel, both to the future and the past.
And we've explored some of the mind-bending paradoxes that come with it.
But even if we could overcome these scientific hurdles,
Yeah.
should we even be messing with time?
That's a great question.
Your sources raise some important ethical considerations.
There are definitely some serious ethical dilemmas to consider.
Maybe we should dive into those next.
Let's take a quick break, and then we can tackle those ethical dilemmas head on.
Sounds good. I'm ready for another brain twister.
Okay, so we've talked about the mind-bending science of time travel and some of the paradoxes that make it so tricky, but what about the ethics of it all?
Yeah, like what are the potential consequences of actually messing with time?
Your sources highlight some really important ethical considerations.
Okay, so for example,
Well, one article you flagged really stuck with me.
which one was that?
It argued that even seemingly small changes to the past could have massive ripple effect.
Like the butterfly effect.
Exactly. Step on a butterfly in the Cretaceous period, and who knows what happens to the future.
Maybe humanity never evolves.
It's a chilling thought.
Yeah, it really makes you think about the responsibility that comes with such power.
If we ever did figure out time travel.
And then there's the potential for abuse, right?
Oh, absolutely.
Imagine a world where governments or individuals could manipulate history for their own gain.
Doesn't take much imagination to see how that could go wrong.
It's a pretty terrifying thought.
You also included an interesting paper on the philosophical implications of time travel.
Oh, yeah, I remember that one.
It talked about how time travel challenges our fundamental understanding of free will.
If the future is already set, do we really have any choice in our actions?
That's a question that's been debated for centuries.
And time travel just adds another layer of complexity to it.
It really makes you question everything we think we know about cause and effect.
But even with all these complexities and potential risks, the idea of time travel is just so captivating.
It's hard to resist the allure, isn't it?
It speaks to a deep-seated human desire, the longing to undo past mistakes or to relive cherished moments.
Or maybe even just to witness history firsthand.
And that's where the power of storytelling comes in.
You mean time travel in fiction?
Exactly. Your sources touch on how these stories, while fantastical, often reflect our hopes and anxieties about time.
They're a safe way to explore those what-ifs and potential consequences without actually messing with the timeline.
It's like a thought experiment without the real-world risks.
Exactly.
Take Back to the Future, for
Oh,
example.
classic.
It's a story about second chances and the unintended consequences of altering even seemingly minor events.
Marty McFly almost erases his own existence.
Just by interfering with his parents' meeting.
It's a great example of the ripple effect we talked about earlier.
You also highlighted Doctor Who.
Ah, yes,
Okay.
Doc.
That show explores the vastness of time and the interconnectedness of history.
It presents time travel as this grand adventure, but it also acknowledges the responsibility that comes with it.
It's not all fun and games.
Not at all.
It's interesting how different stories choose to grapple with the paradoxes of time travel,
Some, like the ones we just mentioned, really emphasize the potential dangers.
while others, like Avengers, Endgame, use the multiverse to create these thrilling alternate realities.
It's a clever way to have your cake and eat it too.
You get the excitement of time travel without the logical headaches.
It seems our fascination with time travel goes beyond mere escapism.
These stories often delve into profound questions about free will, destiny, and the nature of time itself.
It's a way to explore our deepest fears and hopes about the past, present, and future.
So even though we haven't cracked the code of time travel in reality,
Yeah, we're not quite there yet.
our exploration of its possibilities through storytelling can offer valuable insights.
Into our own anxieties, desires, and philosophical dilemmas.
It's a reminder that even fantastical concepts can hold a mirror up to our own humanity.
And who knows, maybe someday our understanding of time will have evolved so dramatically that we'll look back at our current ideas about time travel and chuckle.
Like we were just scratching the surface.
Perhaps time as we conceive of it now is just a limited perspective.
It's mind-blowing to think about.
It is, isn't it?
Okay, so we've explored the mind-bending science of time travel, the paradoxes, the ethical considerations, and the fascinating ways it's portrayed in fiction.
I think we've covered a lot of ground.
We've gone from ancient myths to cutting-edge physics,
It's been quite a journey.
and we've only scratched the surface,
It seems the more we delve into time travel, the more questions arise.
which I guess is what makes this topic so endlessly fascinating.
It pushes the boundaries of our imagination and challenges us to rethink our place in the universe.
Your sources have given us an excellent overview of the complexities of time travel,
They've certainly given us a lot to think about,
and they've left us with a lingering sense of mystery.
which is perhaps the most fitting conclusion to a deep dive like this.
Speaking of mysteries,
Yeah?
I'm reminded of something one of your sources mentioned.
What was that?
It talked about the energy required to create a wormhole, but it never actually quantified it.
That's interesting.
It makes me wonder, just how much energy are we talking about here?
You mean to create a wormhole big enough for a person?
Yeah, and stable enough for them to actually travel through it.
That's a question that could keep physicists up at night.
Yeah, it makes you realize just how far-fetched the idea of time travel really is.
At least with our current understanding of physics.
Maybe one day we'll make some breakthrough that changes everything.
I mean, who knows what the future holds?
Speaking of the future,
Right back to the topic at hand.
we've covered a lot of ground in this deep dive.
We have, haven't we?
From the theoretical physics of time dilation and wormholes,
To the mind-boggling paradoxes of time travel.
and the ethical dilemmas that come with the possibility of altering the past.
Not to mention the ways in which time travel has captivated our imaginations in literature and film.
It's been a whirlwind tour through the mysteries of time.
And I think your sources have given us a fantastic overview.
They've presented a balanced perspective on the science, the possibilities, and the challenges.
Definitely, it's clear that you've done your research.
Well, I'm glad you think so, because I'm fascinated by this stuff.
As am I. It's a topic that never gets old.
Even if we never figure out how to actually travel through time,
Yeah, even if it remains purely theoretical.
the exploration itself is valuable.
It forces us to question our assumptions about the universe.
And to confront the limits of our own knowledge.
It's a humbling experience in a way.
It is, and makes you realize how much we still have to learn.
But that's the beauty of science, isn't it?
The constant pursuit of knowledge.
The drive to unravel the mysteries of the cosmos.
And who knows, maybe one day we'll unlock the secrets of time travel.
Until then, it remains a tantalizing enigma.
A source of endless fascination and speculation.
And a reminder that the universe is far stranger and more wonderful than we can possibly imagine.
Well said. And on that note, I think we've reached the end of our deep dive.
It's been a pleasure exploring these ideas with you.
Likewise, and a huge thanks to all of you for joining us on this journey through time.
Until next time, keep those minds curious.
And never stop exploring the wonders of the universe.